The story of the computer is a story of dreams. Long before the first silicon chip, visionaries imagined machines that could think. Charles Babbage, a 19th century mathematician, dreamt of a mechanical computer he called the analytical engine. Ada Lovelace, a brilliant programmer, saw its potential to unlock a new world of possibilities. Their work laid the foundation for a technological revolution. A century later, their dreams would become reality. The computer age was about to begin. Imagine a computer that takes up an entire room, buzzing with the heat of thousands of vacuum tubes. This was the reality of first-generation computers, behemoths like the ENIAC and UNIVAC 1. The ENIAC, unveiled in 1946, was a marvel of engineering. It could perform thousands of calculations per second, a feat unimaginable for its time. However, programming the ENIAC was a Herculean task, requiring rewiring and resetting for each new set of instructions. UNIVAC 1, introduced in 1951, marked a significant step forward. It was the first commercially available computer and used magnetic tape for data storage, a huge improvement over punched cards. UNIVAC captured the public imagination when it correctly predicted the outcome of the 1952 US presidential election. This event showcased the immense power of these new machines, sparking both excitement and apprehension about the future of computing. The invention of the transistor in 1947 was a watershed moment in the history of computing. This tiny semiconductor device could amplify and switch electronic signals, just like a vacuum tube, but on a much smaller scale and with less heat generation. The transistor replaced the bulky, inefficient vacuum tubes of the first generation, leading to smaller, faster, and more reliable computers. The second generation of computers had arrived. The IBM 1401, introduced in 1959, exemplified this shift. It was one of the first computers to use transistors extensively. The 1401 was a commercial success, finding its way into businesses and universities worldwide. Another notable second-generation computer was the DC-PDP-1, released in 1960. The PDP-1 was smaller and more affordable than its predecessors, making it accessible to a wider range of users. It is considered by many to be the first mini-computer and played a pivotal role in the development of the hacker culture and the video game industry. The next quantum leap in computing came with the invention of the integrated circuit, or IC, in the late 1950s. An IC packs thousands of transistors, resistors, and capacitors onto a single chip of silicon. This miniaturization further reduced the size and cost of computers while increasing their processing power. The third generation of computers, powered by ICs, marked a significant shift towards smaller, more powerful, and more affordable machines. The IBM System 360, launched in 1964, was a landmark achievement of the third generation. It was a family of compatible computers, allowing businesses to easily upgrade their systems without rewriting their software. This concept of a computer family revolutionized the industry. Another key player in this era was the DC-PDP-8, introduced in 1965. The PDP-8 was one of the first commercially successful mini-computers. Its compact size and relative affordability made it popular in research labs, universities, and small businesses, contributing to the decentralization of computing power. The microprocessor birth of the personal computer. In 1971, Intel introduced the 4004, the first commercially available microprocessor. This tiny chip contained all CPU functions on a single chip. It was a game changer. Computers could now fit on a desk or in a pocket. The personal computer revolution was about to begin. The Altair 8800, released in 1975, is considered the first true personal computer. It ignited the imaginations of hobbyists and entrepreneurs. Apple, founded by Jobs and Wozniak, released the Apple II in 1977. It was one of the first successful personal computers. In 1981, IBM introduced the IBM PC, setting the industry standard. Section 6. The Age of Connectivity, Networks, and the Internet. As personal computers proliferated, so did the desire to connect them. The development of computer networks allowed computers to share information and resources, laying the groundwork for the Internet. Early networks like ARPANET, developed in the 1960s, demonstrated the potential of interconnected computers. The invention of the Transmission Control Protocol Internet Protocol, or TCP/IP, in the 1970s provided a standardized way for computers to communicate over a network, paving the way for the Internet as we know it today. The World Wide Web, invented by Tim Berners-Lee in 1989, made the Internet accessible to a wider audience. The web provided a user-friendly interface for accessing and sharing information over the Internet, leading to an explosion of online content and communication. The Internet has transformed how we live, work, and interact with each other. It has democratized information, fostered global communication, and fueled innovation across industries. Section 7. The Graphical User Interface, making computers user-friendly. Early computers relied on text-based interfaces, requiring users to type commands. The GUI, developed in the 70s, revolutionized computer interaction. It replaced cryptic commands with intuitive icons, making computers accessible. Apple's Lisa, released in '83, was among the first with a GUI. The Macintosh, released in '84, popularized the GUI. Windows, first released in '85, brought the GUI to a wider audience. The GUI made computers accessible to all ages and abilities. Section 8. Mobile computing, from smartphones to wearables. The late 20th century saw the rise of mobile computing, with laptops becoming lighter and more powerful. The introduction of the smartphone in the early 21st century revolutionized mobile computing, packing the power of a desktop computer into a device that fits in your pocket. Smartphones, with their internet connectivity, GPS, and a plethora of apps, have become ubiquitous, transforming how we communicate, consume information, and navigate the world. Wearable technology, like smartwatches and fitness trackers, further extended the reach of mobile computing. These devices collect data on our physical activity, sleep patterns, and other biometric information, providing insights into our health and well-being. The line between computers and other devices has blurred. Computers are no longer confined to our desks or even our pockets. They are embedded in our cars, our homes, and even our bodies, creating a seamless, interconnected world. Section 9. The rise of artificial intelligence. Artificial intelligence, or AI, has emerged as one of the most transformative technologies of the 21st century. AI encompasses a wide range of techniques that enable computers to mimic human intelligence, such as learning, reasoning, and problem-solving. Machine learning, a subset of AI, allows computers to learn from data without explicit programming, enabling them to improve their performance on tasks over time. AI is already impacting our lives in numerous ways. It powers virtual assistants like Siri and Alexa, provides personalized recommendations on streaming services, and enables self-driving cars. In healthcare, AI is used to diagnose diseases, develop new treatments, and personalize patient care. As AI technology continues to advance, it promises to revolutionize industries, automate tasks, and solve some of the world's most pressing problems. Section 10. Quantum computing, the next frontier. Quantum computing represents the next frontier in computing technology. Unlike classical computers, which store information as bits representing 0 or 1, quantum computers use qubits. Qubits can represent 0, 1, or both simultaneously, a concept known as superposition. This allows quantum computers to perform computations exponentially faster than classical computers for certain types of problems. Quantum computing is still in its early stages of development, but it has the potential to revolutionize fields such as medicine, material science, and artificial intelligence. Quantum computers could be used to develop new drugs, design new materials, and create more powerful AI algorithms. While significant challenges remain in building and scaling quantum computers, the potential benefits are enormous, promising to unlock new frontiers in science, technology, and human understanding. Section 11. The future of computing possibilities and predictions. The evolution of computers has been nothing short of remarkable. From room-sized behemoths to powerful devices that fit in our pockets, computers have transformed our world in countless ways. As we look to the future, several trends are likely to shape the evolution of computing. These include, ubiquitous computing. Computers will become increasingly embedded in our environment, seamlessly integrating into our homes, workplaces, and cities. Edge computing. Processing power will move closer to the source of data, enabling faster and more efficient data analysis and decision-making. Neuromorphic computing computers will be designed to mimic the structure and function of the human brain, leading to more powerful and efficient AI systems. Biocomputing. Biological systems will be harnessed to perform computations, leading to new frontiers in bioengineering and medicine. The future of computing is filled with exciting possibilities. As computers become more powerful, more connected, and more integrated into our lives, they will continue to reshape our world in profound ways, opening up new frontiers of knowledge, innovation, and human potential.